Okay, so as in the last video, we have solved MCQs from the Ecat book, which was part number 2. Alright, in today's video, we are going to solve the MCQs from 35 to 50, which is the last part of solving the MCQs from the Ecat book of chapter number 5, Atomic Structure. Alright, so today we are, of course, going with 35 to 50. So let me zoom in and let us start solving these MCQs, right? So wait, yeah. Okay, just wait for a while since I need to look on this. Okay, so we are good to go now. Let me zoom in. So what 5th MCQ is asking us about the number of neutron in the element beryllium is. How many neutron are there in the beryllium atom? We need to identify that. Alright, how many there can be, right? So we know that beryllium atomic number is 4, right, which is actually representing what? It is basically representing the protons as well, right? So we know that atomic mass is basically the combination of neutron and atomic number, which is proton. So it is the combination of proton and neutron. If I subtract the proton number from the atomic mass, I can actually get the neutron, which means 9 minus 4 is 5. So there would be 5 electron, right? There would be 5 electron. So our correct option is, wait. So our correct option is 5. Okay, let's go with 36th MCQ. What are they asking us about? Subsidiary quantum number specifies. Now, subsidiary quantum number is basically, you know what, is the name for azimuthal quantum number, and we have another name for the azimuthal quantum number as well, and that is angular momentum quantum number, right? So azimuthal quantum number, angular momentum quantum number, and subsidiary quantum number, they all are the same, right? And we know that what azimuthal quantum number tell us about, the principal quantum number tell us about the size of the orbital, right? So leave the first option, which is not our part, right? Second, shape of the orbital, and we know that azimuthal quantum number or subsidiary quantum number or angular momentum quantum number tell us about the shape of the orbital. So our correct option is B, which is the shape of the orbital, right? So now let us go with 37th, the number of spherical nodes in 3p orbital. How many there would be spherical nodes in the 3p orbital, right? So of course the answer is 1. There would be only one node in the 3p orbital. I think so this doesn't need explanation. Okay, then we have number of neutrons in heavy hydrogen atom. How many neutrons would be there in the heavy hydrogen atom? Alright, so we know that in the common hydrogen we don't have neutron in it, right? If we make it heavy, means we are increasing its atomic mass, which means we are increasing one number of neutron. Alright, so it is B. 39, at 200 degrees Celsius, hydrogen molecules have velocity 10 power 5 centimeter per second. The de Broglie wavelength in the case is, of course, we can take this by the formula, right? We can actually take out the wave number first, then we can take out the reciprocal of that wave number. We can actually get the wavelength, right? We have driven the formula for it, Rydberg's constant, by putting the Rydberg's constant. So I guess that is very easy, and its answer would be, of course, what, right? So its answer would be 2 Armstrong. They are basically asking us about the de Broglie hypothesis, so do not go to the, you know what formulas were made by, the Neil Bohr. That basically formula in which Rydberg's constant was used, it was developed, right? So we need to see the formulas too. What are they asking us about in the model, right? Initially. So 40th MCQ, basically they were asking us here about de Broglie hypothesis, right? So 40th, the electronic configuration of an atom or ion can be defined by the following. Of course, we have read about the electronic configuration rules. It can be explained with the Alpha principle as well, which is basically N plus L rule, right? It can be explained with Pauli's exclusion principle, in which no two electrons will gonna possess same set of four quantum numbers, right? Their spin quantum number, S quantum number would always be different. We can actually define the electronic configuration with the Hund's rule as well. What does Hund's rule says? Basically, we need to give one electron to each orientation, as like we have here P. Wait. For suppose, wait, let me change the color of it and the size of it too. So this is, I have P, right? Here I have 3 in it, right? So initially I need to give one electron to every orbital, that too with same spinning, right? Then if I have electrons left, I need to give from the starting one, and that too with anti-spinning, right? So this is how we give, which means 1 plus 1 rule, which is Hund's rule, right? So we can actually define the electronic configuration by all of these rules. So answer is all of these. What is 41st MCQ asking us about? The electron in an atom. The electron in an atom moves randomly around the nucleus, okay. Has fixed space around the nucleus, okay. Is stationary in various energy levels, okay. What does D is asking us about? Moves around its nucleus in definite energy level. So yeah, this fourth option is of course correct. It moves around its nucleus with the specific energy, right, levels. Okay, so 42 MCQ, the radius of second Bohr orbit is. So we know that for the first one, we have actually 0.53 into n square, right? This was the formula. Because in Z we have only one, so no need to write that. So if you are finding this atomic radius for orbit 1, we can actually write here 0.53 into 1 square, which will gonna give you in the answer same, right? Same 0.53. Now if I am finding this for the second or second, you know what, shell, so I need to write here 0.53. Instead of n square, I need to write here 2 square, which is 0.53 into 4, right? 2 to the 4. So our correct option is C, right? Our correct option is C. 42th correct answer is C, right? Now we are moving towards 43. For which of the following sets of quantum numbers an electron will have the highest? So this is very understandable, right? This is very understood thing, that this one will gonna have more or highest energy, right? Very easy for now. So 44th MCQ, what are they asking us about? So the radius of hydrogen atom in the ground state is 0.53. The radius of lithium plus 2 in the similar state, right? So we have just now we have discussed, we have basically formula 0.529 or 53 into n square by Z is the actual formula. Here we were finding for, you know what, the hydrogen. That's why I didn't write 1. But here our atom is lithium. whose atomic number is 3, so we need to write, right? So 0.5 into 1 square, since they are asking us in the ground state, right? And its atomic number is 3, right? So leave 1. We know that the square of the 1 would of course be, right, 1. So no need to write, I guess, 1 square, because we know that that is 1, right? If I cancel this now, 3 ones are 3, right? And point, 3 ones are 3, 2 here, so 7s are 21, again point, you know what, something something something, so on, right? So 0.17, let's see our answer, 0.17, right? So we have got our answer, that is C, 0.17 angstrom, right? 45th MCQ, Rutherford's experiment led to the discovery of nucleus. Everyone knows, right? Everyone knows. 46, the total number of orbitals in a shell with spin or principal quantum number n is. We need to find the orbitals in a shell. Alright, so we know the formula for finding the, you know what, electrons. However, we know the formula for finding the orbitals as well, right? So what it answer would be, basically when we find the electrons in the shells, the, you know what, the formula becomes 2n square. Oh god, oh god. Okay, so it becomes 2n square. But when we are finding, you know what, the orbitals in a shell, the orbitals in a shell n, so this formula becomes n square, right? So our correct option here is C, right? The formula would be n square. The formula would be n square. 47, the quantum number which determines the shape of orbital. Again, azimuthal quantum number, or subsidiary quantum number, or angular momentum quantum number. So the correct option is azimuthal quantum number, which is used to determine the shape of the orbital, right? 48, heaviest particle is. We need to find the heaviest particle. If I do talk about meson, meson is basically present in the nucleus, right? So it has basically quarks in it, right? So if I do talk about neutron, neutron mass is greater than the proton and electron, so the correct option here would be neutron, right? 49, 4f orbital has, of course they are asking us in nodes here, so 4f orbital will gonna have 3 nodes, right? 3 nodes. Last but not the least, Rutherford's atomic model suggests the existence of, again, nucleus, right? So here basically the key is given as well, but today we have solved MCQs from 35 to 50 onwards, and this was our last part of solving the MCQs from the Ecat book. From the next video we are gonna solve the MCQs from Kip's book now. After Kip's we gonna start our new chapter of the chemistry. So this was all for today.